Hey guys, it's Mr. Dugal, and today we're going to talk about compound interest in terms of how it relates to exponential growth compared to simple interest and how it relates to proportional or linear growth. So first, just to review our formula for simple interest, the way that we've talked about remembering simple interest before is the equation and the saying I is Purdy, I is per t, where I is interest, P is principal, R is the rate, T is the time measured in years. If it's out of an amount of months, we need to divide that by 12 and take that as a fraction or a decimal. So P principal is the amount originally invested. I is the interest made off of that principal, or the interest owed if it's a debt. R, the rate, is the percent we make. And T is the time and years of the investment. So, to use an example, we're going to pretend that we have $65,000 as our principal. So $65,000 is the amount we're investing. We know that we're going to make 5%. 5% as a decimal is 0.05. And we're going to invest this for 20 years by using simple interest, and then we're going to break it down by 1 year. So 65,000 times 0.05 multiplied by 20 years gives us $65,000 exactly. So we make $65,000 in interest. So we invested 65, and then we made 65,000 in interest. So our total amount of money after 20 years would be $130,000. In each year we make a fixed amount, and that fixed amount is $3,250. So each year we make interest of $3,250. We multiplied that by our 20 years and it gave us $65,000. So basically in 20 years, following simple interest, we double the amount that we make. Alright, compound interest is our table up above, and this works a little differently. With compound interest, it's not a fixed amount. So with simple interest, we had this $3,250, and after year 1, we made $3,250. After year 2, we made $3,250. It's the same amount, it's proportional growth, it's how much we make each year. A good way to think about that $3,250 is it was basically our slope. So we started out at $65,000 as our y-intercept, and it grew $3,250 a year. If this were slope-intercept form, it'd be y equals $3,250 times x plus 65,000, because that's how much we started with. That was our starting point. Talked about how y-intercept, a good way to think about it is our starting point, and a good way to think about slope is the amount we're growing. So that's how simple interest works. Compound interest is totally different. Compound interest, when we're done with it, is going to look like exponential growth. It's going to be a curved line, it's going to be non-linear, and it's not going to be proportional growth, it's going to be exponential. Okay, let's talk about why. So over here we have our formula. After year 1, we're going to end up making the same as if it were simple interest. So you can see the difference between $65,000 and $68,250 is the same amount that we made in simple interest. It is $3,250. However, the very next year, this amount changes. If it were to be $3,250, then we should have $71,500. However, this is not the case. You'll see our first year, instead of having $71,500, we actually have a little bit more. We have over $100 more. And the reason for that is the interest we make is no longer made on simply the original amount invested. In other words, with simple interest, we were always making $3,250, because the 5% was always off of the original investment, the $65,000. In the financial world, we call that $3,250, that stable income every year, that stable investment. We call that a dividend. However, with compound interest, it's a little different. With compound interest, we make that 5% not only on the $65,000, we make it on the amount we now have. So the next year, we make 5% of $68,250. This year, we make 5% off of $71,662.50. So if we are the person gaining interest, if we are the person earning interest, this is a really good thing, because we're earning interest on a bigger amount of money, which is why our growth is exponential. However, if we owe money, if we have a credit card debt and we owe the money, this is a really bad thing, because we don't want to be the person owing exponential growth. We want to be the person receiving exponential growth. I'm going to drag this down. You can see after year 1, it was a little bit different, but over 20 years, this becomes a major difference. So you can see that in comparison to ending with $130,000, we actually end up with $164,251.76 over the same amount of time, and that's because of the compound interest. That's because we are earning interest on the interest. And that, as shown on a graph, is exponential growth, and it's nonlinear growth. It's different than simple interest. Hopefully this helps you moving forward. Thanks so much for watching.